So welcome everybody. I'm going to introduce myself. My name is Massimo Nocentini, and I come from Italy, and I have a PhD from the University of Florence, and now I work as a freelancer, and I had the opportunity to work with Smalltalk after my PhD. And first of all, I would like to thank the Faro board to let me be here, and also I would like to also thank Richard and Pavel for many reviews, many discussions, and all this work is also by the help of both Richard and Pavel. And also I would like to thank Pablo that helped me with some VM stuff. So let's start. Today I'm going to present notebooks. Notebooks, I have here a kind of plan for my talk, and it's all about documentation. And in particular, I'm going to begin with my personal needs for expressing idea and collecting different sources that I think that are beautiful, and how can I place and play in the same environment. Then we are going to introduce two new ROASL shapes, in particular Pango and PDF shapes. And then we see how we can stretch playgrounds in order to have something like a notebook. In their final part, I'm going to show some extensions for Microdown. In particular, we will see something with LaTeX and TXZ and also the 3Zder library. And finally, we see how we can take advantage of the uniformity of Faro Smalltalk and integrating all this stuff into our tooling. So that's the main plan. As I started before, also during the PhD and our work, very often I encountered the situation that I had, for instance, a piece of documentation that it's, for instance, in the form of a short PDF, or you have a nice mathematic formula, and you want to say, yeah, I want all these small pieces collected together in just one uniform and well-defined document. And for instance, during the PhD, I studied computer science and mathematics, so I used a lot of symbolic computation, and in particular, I used Jupyter notebooks in order to do something like reproducible research. But Jupyter notebooks, yeah, they are cool, they are very flexible. You can append and use different kernels if you want to interpret different expressions according to the language that you want to use. But they are a kind of static, so you have a flow that you have to respect. So you start from the top and you start writing something, you evaluate, and you have a string representation of your objects. But yeah, you know, if you have objects and if you have a lively environment, you can do more. You have this feeling. And that's the main, how can I say, the first start that and the main need that I had and continuously I have. So I've tried to fulfill of this limitation, and but yeah, you know that we have Leviter around. Yeah, that's a very good stuff. It's a very impressive framework. But if you want to load everything, it's how can I say, a bit heavyweight. So I prefer to remain humble, to remain very simple. So start with a very vanilla Faro image and try to use the tools that we have. In particular, we will see Russell in particular. So let me start by, oops. Yeah, that's a nice playground. It's the place where you have an idea and you start typing something because you want to experiment with what you are thinking about. So I've prepared here a content, and I would like to reason about with you about how we usually play inside this environment. Yeah, we have actually a sequence of small talk expressions that we want to evaluate. And possibly we also can type something, for instance, here, that's comments. So they allow us to clarify our thoughts in order to say what we are trying to evaluate. But from the point of view of the real computation, comments are useless. So you don't give values to comments other than the ones that are helpful for your reasoning. And yeah, for instance, if I evaluate all of this, I get the final value, which is done. In fact, the final expression is a very simple string. But all we have here, yeah, it's okay, has been evaluated, but we lost it. So in order to give value also to comments, it's the reason why I've tried to stretch this tool a little bit. But before going to see a new presenter, I would like to show you these two basic building blocks that will play a crucial role also in what we are going to see. So now I'm going to introduce two new shapes. I can show you here directly. For instance, yeah, this is what I've called a Russell Pango markup shape, and actually it allows you to format a paragraph of text according to the Pango markup language, and Pango is part of the GTK framework. And the important thing in my eyes is that you have a paragraph as just one shape instead of a composition of Russell labels. So here, let me shrink this. As you like, as you see here, we have hello, then we have some space, and then we can use this kind of markup formatting. For instance, we want to use a different font family. We want to have a larger size for the text, and put it in red, and we have finally the content, which is Word. And that's it. We can use the power of Pango directly in our ROASL visualizations. That's the first building block that will be really helpful in what follow. The second one, which is also quite nice, is it's a new shape that allows you to integrate a PDF page directly in your ROASL visualizations. And also, this is just one single shape. And if you have a PDF, you can readily iterate over all the pages and put all of them here, and you can read your PDF books also directly on a Faro image. This is just a simple ROASL visualization, nothing more. So, by the way, this page is one of the page of the Faro by example book that shows the object model of Faro. So that's really nice. So let me close this, and I'm going to use and to load the same content on this different presenter. I've called Notebook. The style is actually similar, but you have a new button here, Outline It. So let me press this. Yeah, here we have some more stuff, and I'm going to make it bigger. Yeah, here we have a big containing box, and is this one. And as you see here, we have a kind of two columns. The one on the left is used to represent the expressions that we want to evaluate. And a main right column that represents the flow of your document. The interesting thing is that we can now use comments in order to actually describe what we are going to experiment. For instance, if we have just here, we see that we can recognize that the first comment allows us to put an either with ESUG notebooks and then some string after. Then we have a small talk expression that it's actually evaluated to this. And by the way, also this representation is another consequence of our work. And we call this kind of representation outliners, because these allow us to render objects, but we can have different views for such objects. And here we have a simple byte array, and of course you have the full byte array here, and you have the string value, which is okay, but you can also, for instance, inspect how the bits are actually in memory. And you can customize the representation of objects as you like. So let me go a little bit here on the bottom. And yeah, here we encounter again our simple hello world shape. And here we have our PDF page. And all inside the same ROASL visualization. This is nothing else than composition of ROASL shapes. So before going to the extensions, I also would like to show you the browser here for Microdown. So I navigate to the syntax file, and yep, here actually we show that all the Microdown syntax, almost all, to be honest, I have to implement the tables, but almost all the Microdown syntax is well supported, and we have, for instance, numbered headers, and we have bold, italics, strikes. Yep, this is what we usually represent with the normal document browser, but using Russell instead of just the rich text. So, yep, we have also links or chunks of Smalltalk code, and yep, obviously images. So, so far so good. Let me now show some extensions that we can use if we want to integrate something more complex. For instance, if you have on your machine a LaTeX attack compiler, you can, for instance, I make it bigger. You can, for instance, have really beautiful mathematics expressions, for instance, this one. Or you can evaluate TXZ scripts in order to compile a small PDF and just plug in here directly in your representation. Another component that's of particular interest also for writing documentation is the tree-seater library. Tree-seater is used by GitHub in order to highlight code in different languages. And it's a very simple library written completely in C. It's actually simple also to compile. And here we have integrated this library in order to be able to parse arbitrary languages. And at the moment, I just ported C, JSON, JavaScript, and Python. And here we can see the corresponding shapes. So this is a very simple int main. Here we have a JSON. Here we have JavaScript. And finally, we have Python. So all of this has the property that we have no class hierarchies for every language. Tree-seater is designed to have just one single representation for a tree, an abstract syntax tree, and we mimic the same, but everything is done by a VM plugin to be as fast as possible. So having time, for instance, this is the list of all available parsers for tree-seater. So it's just a matter of just starting working on this and integrating a new language in the compilation of the VM plugin, and all is transparent. We can just use it really in a transparent way also in our Smalltalk images. So in order to close the presentation, I would like to show how all of this can be integrated also in the Faro tooling. And for instance, here you see a very small tech tab. And yeah, this is nothing more that the evaluation of this small method. And that's my initial the 2 slides. So this is plain tech code, and yeah, you're able to just say, for instance, let me just change a message and go back here. So this is compiled on the fly and integrated this here. But of course, you can do more. And for instance, this message allows us to read a small portion of a chapter by followed by example book. And for instance, let me open this script and go into the slots graph here. This is quite yep. We can just read the whole chapter about the object model directly in your image here. And this is just an inspector, but for instance, if you like to have it directly in Eclipse browser, you can simply visualize the same stuff in 2 columns here. And you can play with these kind of representations. And for instance, since we have these 2 basic shapes, for instance, we can go to the object class, and here we have one of the most important comment. But we can also, for instance, visualize it directly in a new tab here. And of course, you can use all the power of microdom, interpret it using Russell, and put it all together here. One more thing that I would like to show is also, for instance, this one. So this is another very simple method that actually should be implemented, but pay attention to this kind of comment. Microdom supports the faraway val environment. Yeah, so in this case, since this is a message, a compiled method, sorry, and of course we can inspect such a method. So here we have another tab. Let me make it bigger. That allow us to have a representation of such compiled method. Yeah, it's installed in the libpoppler test case class under this no protocol. And yeah, here you have the actual body. But our comment, which is here, just evaluate the following. We are able to use the same evaluation process, and all of what we have done before, we can directly use here. And that's the same evaluation that we did before with the notebook outline it button. Here I have just datetime now, and this is our way to show a datetime. So I think that all those small pieces, if we collect together and play by their, how can I say, transparency, it's really useful because allow you to put into the same document different sources. So you can generate on the fly some stuff, you can import some pictures, PDF, and all of this is a collection of raster shapes organized in this way, but of course you can manipulate and produce your raster visualization. We have some VM plugin that supports all this implementation just for the sake of speed. That's the main reason. But all of this can be loaded by in a fresh Faro image, and yeah, that's it.
So with this, you are integrating the external PDF world inside interactive notebooks inside Faro. Have you think about, like, I don't know, for example, adding, let's say, PDF annotation capabilities inside Faro, that you can import a PDF and take notes on the PDF, for example, using the computational capabilities of Faro? That's my first one. And the second one is related with the way that you can, let's say, integrate documents or interactive documents or computational notebooks with the external world of HTML and other outputs that are not in the image but outside of the image. How are you envisioning to exchange notebooks with other people? What would be the format or the way of publishing outside of the image?
Yeah, for the first one, actually, the library that's behind this, it's called libpopular. And there's a very rich API, all written in C, and allow you to, for instance, inspect anchors, links, annotations. You can write something on the PDF. You can set some properties, for instance. And for the second question, till now, you can export all of this, and but whatever you can export by raster, you can export also this one, so on PDF, SVG. But of course, toward the web, there's a lot of things to do, because there is no a ready exporter for PDF. For exchanges, this is just compiled method. So you just version your code, and you can load on a different image, and that's it.
Anybody else? Thank you. You mentioned the use of LaTeX, and you said you need external libraries to do that. What are you using there, please?
Personally, I use the TechLive implementation, which is pretty and usually available also on the major platforms. Also on Windows, if you use MSys2, there's all compiled implementation of TechLive, and there you can find, for instance, PDF LaTeX, LuaTeX, or XeTeX, all the compilers that you like.
So yes, so you know, so I like what you are doing. I try to understand what I can do with it for what I want. So you see, so what I would like free to extend. So I would like to have a kind of, maybe this is like a Jupyter notebook. So I would like to be able to mix text, to have special nodes where we can see the results, and that we can have a mode where we could edit the script behind, and then see the rendering. So this means that I guess that we could do something that goes in that direction with what you are doing.
Yeah, that's a good idea, because right now you just write on the space on the code presenter, and then outline everything. But having more interactivity, yeah, it's a good step forward.
Yeah, because you see what we, if someone is interested to join, or so what we would like, I don't know if you know ProfStep, so this is a stupid tool to so that the student can learn how to program or learn the thorough syntax, and then we would like to have ProfStep on steroids. And then with how it's called, Domenico want to have MasterLu. So MasterLu, this is ProfStep but for music. So we would like to have live tutorial and things like that that goes in that direction, because also in Microdam we can just have extra node where we can do things. So if you are, we should discuss, because I would really like to see what we can do from that perspective. And I know that Alexandre is also interested to have a tutorial for Core Mass, where he could embed things inside, so that would be super cool.